Previous video we talked about gyrator, right? And the previous video we talked about the positive feedback and negative feedback. And then another thing I want to take note is that gyrator itself um is simply a non-inverting um it's actually a negative feedback lah. It's actually a negative feedback system. Okay, I actually forget to write it down. Yeah, so I should write down over here. So gyrator is actually a negative feedback. So the gyrator may actually use as an amplifier also lah, but okay, I'm not gonna go through in a more deeper sense. And you may actually confuse a lot of things. So let's talk on gyrator here. So gyrator is a negative feedback. You're connecting your feedback to a negative side. So let's talk about active filter and buffer filter. What the hell is that? So if you remember your capacitors and your inductor video, right? You will talk about filters, high pass, low pass. So in this case, it's the same thing about here. So if you were to take a look, yeah, where are we? Yeah, okay, gyrator, and then so buffer filters. So buffer filters means that you create a buffer, okay, atop a filter. So you remember this is actually what? This is actually a low pass system, a low pass filter. So if you were to put a buffer over here, what you're gonna do is actually to isolate the component, right? So if you remember, buffer is actually to isolate the component. So in other words, you're gonna isolate this thing. So this thing will, if you were to connect in series with another like filter, right? So if you are to connect in series with another filter, so like series, right? So this buffer, okay, is gonna isolate this component from this thing, from all these things. So it is by definition is buffer lah, right? So what is it? How does it isolate the component? As it says, the infinite input impedance and a zero impedance ensure that the RC component will experience no loading effect. So whatever voltage in, right, in this case, the capacitor will be like so-called so the voltage across the resistors and the capacitor will not like go in rounds, will not like go in round and round and round, and then may actually take in some voltages, because in this sense, right, the some of the voltage will actually flow into the capacitor, which may actually hold on a certain amount of voltage before it disperses, because as the frequency increase or decrease, the capacitor takes time to discharge or charge. So yeah, so in this case, the buffer itself allows the voltages to flow, because in this sense they're actually a closed circuit, right? So the voltage actually may hold out all this, may actually continue to charge this capacitor in the sense. So in this case, you don't want the capacitor to be charged for some reasons. So you allow all the voltage to flow and then flow through this buffer. So this buffer will flow through this non-inverting side. Alright. So you allow the cleaning of the noises. So because if you were to connect just simply this one, and then you connect with another system over here without a buffer, right? So the whatever residual voltages may actually affect the whole system, right? May actually, because let's say your Vin is like 5 volts, and then this one goes to 5 volts. Well, however, as time goes by, is this capacitor discharge, you actually increase the voltage over here, like 6 volt or 7 volt, or the other way around. So you affect the whole system drastically. So with this buffer, what you're gonna do is actually to ensure that, because you know that the buffer itself has to ensure that the positive and the negative input shares the same voltages, right? So if your V in is 5 volt, you ensure that your Vout is also 5 volt, right? So this is the feedback system. So this is very important concept of a buffer thing, right? So yeah. So nonetheless, for high pass, yeah, you're gonna. So this is simply a high pass, while this is the buffer. As you can see, the buffer itself is connecting to the negative feedback, right? It's connecting to the negative feedback, while the Vin is to the positive side. Okay, so this is a non-inverting system. Anyway, whatever. So I think this is a clearly understood thing. So this is a negative feedback, while input is to the non-inverting side. So this is a buffer filter. So this is an active filter, buffered filter. So this is just buffer filters. That's all. So if you want a so now let's talk about buffered filters with gain. Okay, if you want to amplify your input, okay, you want to amplify your input. Now you're gonna connect your Vin into the inverting instead of Vin into the positive side, right? If you don't want anything, if you don't want to amplify your voltage, right, you can just connect using this one. That's it, right? This is a simple one. If you want to connect using if you want like a gain, amplified gain, you actually connect your Vin into the ding ding. What the hell? Hold on, never mind. Yeah, I said wrongly, so we just ignore what I said earlier. This is actually non-inverting. It's still non-inverting. Okay, it's a non-inverting amplifier. Okay, non-inverting amplifier. Damn it. This is exactly the same thing as if you are to bring this one over here. It's exactly the same configuration. It's just that I add in a resistors over here and a resistors out here. Right. This component is exactly the same thing. If I will take this out, okay, they are exactly the same. You see, they're exactly the same because they are both low pass. However, this is a filter. This acts as a filter. This acts as a filter plus a gain. Right. So it's a double buy one get one free type of thing. So if you remember this, when you're connecting this configuration, you're actually amplifying certain things, right? R2 over R1. Then since you're connecting your input into the positive side, you have a R2 over R1 plus 1, which is the equation over here. This AB is your gain. So this is when you connect your buffer. If you want a buffer and a gain, you can actually connect in this manner. So as you can see, op-amp trumps all the filters already, the high pass and the low pass filter already. So actually yeah. So in other words, right, op-amp itself, it is not high pass or low pass. It's just high pass or low pass buffer filter. So I should change it lah. So hold on. So as you can see, sorry, the buffer filter the purpose is to buffer the whatever low pass or high pass filter. So actually I should elaborate here easy, like more whatever. Ta-da! And what the hell am I? Hold on. So for a non-inverting amplifier buffered filter, okay, buffer filter with gain non-inverting, you use the same equation for the amplifier equation, right? So if it's a high pass with buffer and gain, if it's a high pass, what the hell? Okay, never mind. So if it's a buffer gate filters with gain, however, you want the minimal components, okay? Now this is not minimal components, so it's like a lot of components. It's component intensive. If you want it to be like very little component, lesser components, you can actually use an inverting buffer. This ding ding. This is also non-inverting. Okay, sure, yeah. So your Vin is also in input into the non-inverting side. However, your feedback you can connect in this manner. Your capacitor is parallel to your resistors. For low pass, alright. Just stop here first. Okay, now continuing with another video on buffer filters with gain minimal components. Because this is not the final solution yet, I believe. you have to change it into inverting. Okay, so the explanation is quite long, so I'll just do it in the next video. So in this video, you just need to know how does the buffer filter affects your low pass and your high pass, and then what if you want to gain, how you want to connect it. Okay, so in this case, yeah, we are done. So next video we'll talk about what if you want the minimal components, what can you do. So I'll see you there.